Hello, Mr. Claudia here, and today we are going to continue looking at integrals, but today we are looking at some tough indefinite integrals. However, as I've told you, the type of derivative questions we can give you can be really hard, right? They're questions that involve chain rule and product rule. But when we're going the other way, when we're going backwards and finding the antiderivative or the integral, we can't really ask you too many difficult questions. We don't give you as many tools for integration in high school. In university, sure, you'll have some very difficult integrals, but in general, the ones you're going to see in this course are actually not that tough. So let's replace this tough with not so tough indefinite integrals, because we're going to find that these are the hardest type of integrals I can give you, and they follow the same patterns that we've already seen. So let me show you the different types of integrals the different type of tricky ones you can get. Well, first of all, let's consider this derivative. What's the derivative of 3x plus 7 to the power of 4? Well, if you guys remember, I bring the 4 down. This is chain rule, right? It's 3x, it's something to the power of 4 becomes 4 times that something now to the power of 3, and then I have to have the chain rule, which is 3. So this 3 is the derivative of what's inside the bracket. This is a relic, or what do you want to say, like an artifact of my chain rule. So I want you to just observe that the chain rule, you could say it contributes an extra coefficient. So that's kind of the basis for what we're going to be doing today. We're going to be doing this backwards. So for example, what is the integral of 3x plus 7 to the power of 3? So this is essentially a chain rule question, right? And chain rule is tough. But basically, we want to find the integral of something to the power of 3. So let's think about this. What would that be? Well, let's try, okay, so if I was doing an integral, normally it would be something to the power of 3. So I add 1 to this. So it's going to be 3x plus 7 to the power of 4. And then because I don't want that coefficient in front, I have to put 1 over 4 in front. And then, of course, don't forget, plus c, right? Always indefinite integral. Okay, so we tried that. Let's check it. How can I check if my integral is correct? Well, I take the derivative of this, it should give me this. So let's see, what is the derivative of that thing I just found? So it would be 1/4 3x plus 7 to the power of 4 plus c. Okay, let's look at what the derivative of that is. Well, okay, so the quarter, let's ignore that for now, because the quarter we don't look at. So the 4, when I'm looking at the derivative now of this term, okay, so something to the power of 4. Well, the 4 comes down, then I have 3, that's something, 3x plus 7, now to the power of 3. But then I have to take the derivative of the interior function, which is 3. So I end up with, these 4's cancel out, so I end up with, and then I have a 3 times 3x plus 7 to the power of 3, which does not equal what I started with, which is 3x plus 7 to the power of 3. So the thing that I tried, the guess that I had, didn't work out. The derivative of this does not give me this, because there was all this extra 3. That 3, where does it come from again? It comes from the chain rule. So this number here, we need to get rid of this chain rule constant. So whatever answer I got here, to get rid of the 3, I would have also need to divide by 3. So let's try that answer. So let's try 1/3, 1/4, 3x plus 7 to the power of 4 plus c. Okay, so that gives me 1/12, 3x plus 7 to the power of 4 plus c. Okay, to check, I have to find the derivative of that expression. So 1/12, 3x plus 7 to the power of 4 plus c. Okay, let's find the derivative of it. So the derivative, okay, so the 1/12 I'm going to ignore. The derivative here is going to be 4 times 3x plus 7 to the power of 3. Don't forget that times 3, that's the chain rule. And now some things cancel out. So 4 goes into itself once, it goes into 12 3 times. Oh, then the 3's cancel out. So I'm left with 3x plus 7 to the power of 3. Yes! That answer is the same as what I started with. That means that this answer is correct, right? The derivative, or this integral is correct. Because if I take the derivative of it to check, I end up with that. So this is perfect. So I got the correct answer. So the lesson here, the idea is that there's an extra constant that comes up from the chain rule, and I need to make sure I divide that. I have that in my final answer. Basically divide my answer by that constant. So let's try doing this. Watch. So I have an integral. Again, I don't like to write it with the square root. I like to have half exponent half. So this is chain rule, function within a function. So when I find this, when I solve this, well, first I start with something to the half. What's the integral of that? Well, I take that something and I add 1 to the exponent, so I end up with 3/2. Then I need to have something in front to undo this when it comes down. That's going to be 2/3. But I'm not done. I also have to have something to get rid of the derivative of 5x, which is 5. So I also need a 1/5. So that's the way I like to reason through this. I like to use reasoning and just go through it step by step. Remember, you can always check your answer over if you're not sure. That's the great thing about integration. And there's my answer. What about this question? Well, let's rewrite it into something that makes more sense. The 4 can come right out. I don't really care about it because it's just a constant. 2x minus 3 to the minus 2 dx. Okay, this is chain rule. This is a function within a function. So let's figure it out. So the 4 I'm going to ignore. Let's start over here. Something to the -2. Well, that's going to be something. Now I add 1, so this is going to be to the -1. Now I need a coefficient in front to undo the -1. Well, that's just going to be -1. And then I need a coefficient to undo the derivative of this, which is 2. So I need a half in front. Whew. Then I need a plus c somewhere. Okay, now I just clean this up. So I figure I get 4 divided by 2 with a negative, so I get -2 over 2x minus 3 plus c. Again, that's the way I like to do these questions. I like to reason through them. Those are never too bad. But if you're someone who likes kind of a formula, a plug and play formula, these are not on your formula sheet, but maybe this is the sort of thing you'd rather see. If I have the integral of a function within a function, well, I deal with the exterior function, so I add 1 to the exponent, put this in front, the exponent, 1 over the exponent in front, and then I need an extra term, there's that extra term again, which undoes the derivative of the interior function, so basically 1 over a. So you could just plug and play with that formula, but again, it's not on your formula sheet. Similar formulas exist for the ln and e functions within a function, or chain rule situation. You have the integral of e to the something is e to the something, but then you need an extra term in front to undo the derivative here, the chain rule. Similar here, you need a little term to get rid of the chain rule. This is it, right? This is the toughest type of question I can give you with chain rule. if I ended up having something that wasn't linear inside as the interior function, for example, if I had x squared here, I can't solve that in high school math because the derivative would be 2x. There would be an extra, not an extra coefficient, but an extra x term, which would complicate everything, product rule and all that. This is hard to explain right now, but as you do some questions, you'll see these questions aren't bad. They're pretty easy because the interior function is always going to be linear. It's always just going to give you a constant. So all you have to do is undo that constant. Undo the 5, the 1/5. That's for all of these. So let's do a few more integration questions. Again, I like to do it reasoning, but you could use the formula. So here I have e to the power of something. What's the integral? Well, e is a magical one, right? It's the same. But then I need to undo the derivative of this from chain rule. So there would be a 2, so I'm going to put a half in front. That's it, plus c. If you want to check, again, you're not going to get marked on checking, but this is something you can do if you're not sure. So I take the derivative, that is half e to the 2x plus 5, and then derivative of the top, which is 2, so that cancels out, and I get e to the 2x plus 5, so that works. Check is good, because when I take the derivative of my answer, it leads me back to my integrand. Okay, part B, I have this difficult question. Let me rewrite it as integral of 6x plus 3 to the negative 4 dx. What is the integral of something to the negative 4? Well, it's going to be that something to the negative 3, then I need a negative 1/3 in front, and then I need an extra term to deal with the 6 here, so that's going to be 1 over 6. I end up with negative 1 over 18 6x plus 3 to the power of 3. Oh, plus c. Finally, we get this question. This coefficient in front, let's get rid of it. So I have 3 integral of 1 over 4x minus 2. Now, I think this is the toughest application of this concept. What's the integral of 1 over something? Well, it is, I'm going to leave the 3 out, it's ln of that something. And then I need an extra coefficient in front to undo the 4, that's 1/4. So my answer becomes 3 over 4 ln absolute value 4x minus 2, or 3 over 4 ln 4x minus 2. Oh, sorry, I'm forgetting the plus c's. Where x is greater than 2 over 4. Now, why do we have, sorry, the plus c you guys should know. Why do I have the two answers here? Well, this answer, I think it's easiest just to put absolute value bars around your answer when you find the integral. Because that tells me this has to be positive. But if you want to just write it as regular brackets, there is a restriction, right? This has to be positive. So this has to be greater than 0. If I rearrange this, I can find 2 over 4. X has to be greater than, this has, sorry, let's do it over here. 4x minus 2 must be greater than 0. So 4x has to be greater than 2. So x has to be greater than 2 over 4. So that's how I got that. I don't care which way you wrote. I was taught to do this. It's quicker, right? You just put absolute value bars, and that tells the math, tells you about the restriction. Now, I find this question is confusing because when I see this, I think, oh, I want to use the power rule. And so I'm just going to write a little note, don't use the power rule. I think we talked about this in a previous lesson, but it doesn't hurt us to do it again. When you see this, 1 over 4x minus 2 dx, you might think, oh, well, let me rewrite that as 4x minus 2 to the negative 1 dx. Okay, and then let me just use my, let me just treat this as any other integral. Well, watch what happens when you do that. You get Okay, so what do you have to do to this? Okay, you're going to add 1, so you end up with 4x minus 2 to the power of 0. But then you bring down the 0, so you have 1 over 0. That's a big problem. So quickly, if you do make this mistake, quickly you realize that there's a problem because you can't have this divide by 0. And you're like, and you should be like, oh, wait a sec. Oh, right, this is a situation where I have to use ln. So be careful, right? In this case, you can bring it up to the numerator, turn it into a power law question. But in this question, where it's just to the power of 1, there is no exponent, then it's ln. It's what you have to use when you find the integral. And there's kind of the reason why it doesn't work out. Whew. Okay, so that is our tough questions. Those are our integrals. And like I said, they all have that form ax plus b. The extra constant is always coming from the chain rule. Let's turn the page over and look at the other type of difficult questions. You might see a more difficult question that you can really only solve, which it looks like a reverse chain rule. So this question, for example, the integral of this, you might be able to guess what it is. So what's the integral of something to the power of 4? Well, that would be that something to the power of 5 with a 1 over 5 in front. And then let's leave it like that. What happened to this thing? Well, that looks a lot like the derivative of this. That looks a lot like a chain rule. Let's check. Remember, my check is if I take the derivative of that, I should end up with this. Well, the derivative of 1 over 5, 3x squared plus 5x to the 5 plus c. So that is going to be, okay, so I take the 1/5 out. So the derivative of something to the power of 5 is 5 times the something to the power of 4. But then you have to do chain rule, which is the derivative of the inside function, which is 6x plus 5. And so I end up with, okay, these things cancel out. So I end up with 3x squared plus 5x to the power of 4, 6x plus 5. Oh, and it works out. Great. So with these difficult, these more difficult questions, where these two terms here, or these two expressions, it will kind of always be a reverse chain rule, where very conveniently this bracket is the derivative of this, so that it works out perfectly. If I take the derivative of this, it leads me perfectly to that expression, 6x plus 5. There might be a coefficient or two off, but it's very convenient that this is here, right? If it was 6x plus 8, all of a sudden nothing would work. But because they've given you the exact derivative of this, you can actually solve this by reverse, it's like a reverse chain rule. Usually you can do it by inspection like this. You can almost just guess and then play around with the coefficients until you figure it out. Like, it's always very convenient. But I can show you a method to do this reliably every time. It's called the substitution method. If you like it, you can use it. If not, you can do it by inspection. Just find the answer. That's okay. So watch what happens. Let's just the substitution method. I have an integral with some expression and then another expression. Oh, that looks scary. In this situation, you're going to follow these steps. So set u equal to the expression inside the brackets. Look for the thing with the highest exponent. Well, here's the highest exponent, 4. So the thing inside the bracket, I'm going to call that u. So we're going to let u equal 3x squared plus 5x. So far, so good. Now, find du dx and isolate for du. So that means, can you find the derivative of u with respect to x? Oh, and you're like, yes, I love derivatives. Du dx. So derive this with respect to x gives me 6x plus 5. Now, I want to get du by itself. This is weird, right? I told you du dx is a fraction, and it is, but in this case, we're going to show you how we can break it up. So this is more of an idea, but it helps us do the substitution. I'm going to cross multiply, so I get du times 1. So du is equal to 6x plus 5 dx. It's a cross multiply, right? Okay, now look. This 6x plus 5 dx, that whole thing I would call now du, because that's what it is. So now I want you to rewrite the original integral in terms of u's and du's. So I've kind of already done it here. This is going to become the integral of u to the power of 4, and then this whole thing is actually just du. Well, now that is an easy integral if I've ever seen one. Now we just have to integrate for u, which is going to be 1/5 u to the power of 5 plus c, of course. And now my last step, I wasn't trying to find the integral with u's, I want it to be for x's, so I have to sub back in the expression for u. So this is the easy part. I get 1/5 3x squared plus 5x to the power of 5 plus c. Ta-da! There it is. Now, again, if you like, you could have just done it by inspection, but the substitution is very reliable. We're going to do 2 of these questions, and then we'll call it a day. So I have a practice. Okay, so I have this difficult integral. It looks like a product rule, or sorry, a quotient rule, which is really hard because we don't know the quotient rule for integration. Where is this question on my sheet? Oh, there it is. Okay. Oh, sorry. I want to do, yep, no, this is right. So now what I can do is look for the thing in bracket, or the higher exponent. So, oh, this one has higher exponents. So I'm going to define that as u. Actually, if it makes us a little bit happier, I'm going to rewrite this as 1 over 3x to the power of 4 minus x cubed times 12x cubed minus 3x squared dx. We can even write it like that. Either way, a b in here. Oh, there's a b. There's a b. This is a u. Whatever way you want to look at it. So now we're going to do the substitution. So we're going to let u equals 3x to the power of 4 minus x cubed. That was my step 1. Step 2 is take the derivative with respect to x. So du, the derivative of the u expression with respect to x, is 12x cubed minus 3x squared. And now we cross multiply and we get du is equal to 12x cubed minus 3x squared all times dx. So that was my first part of my substitution. Now I want to rewrite the integral in terms of u's. So, okay. So this was 1 over u. Now 12x cubed minus 3x squared. There's that conveniently, it's the same as my chain rule, right? It's right there. So this whole thing is now du. So when I rewrite this, it's going to become integral of 1 over u, and then this whole thing becomes du. Well, that would be ln absolute value u plus c. Almost done now. I just have to sub in the expression for u, which is defined over here. So I get ln 3x to the power of 4 minus x cubed plus c. Again, you might have been able to jump to this just by looking at this, because it's very convenient that this is the derivative of that. Okay, let's do one more question. Integral of, product rule. This looks like a product rule situation. And we know that we can't integrate product rule. So probably this is something very convenient, where the derivative of this leads to that. So you might be able to figure this out on your own. Let's try doing it with substitution. So we have this thing, which is u. We're going to define the thing inside the bracket as u. So we let u equal to 4x squared plus 1. My next step is I take the derivative with respect to x, so I get 8x. Okay. So then I cross multiply and I end up with du is equal to 8x dx, which is great. Now, but look at this problem here. So I have the integral of e to the 4x squared plus 1, and then I have x dx. So the nice thing is that this becomes u, but now look at this whole thing, x dx. du is 8x dx. So really what I need to do, like technically this is, the only way I get x dx here is I would have had to divide this whole thing by 8 and this whole thing by 8. Then I have a situation where I have du over 8 is equal to x dx. There we go, that's a good match. Now this x dx, I can just replace it with du over 8. So there was an extra coefficient that I had to look at, but if I just methodically manipulate this with a few coefficients, I can make it so that the thing I'm left with, I have a direct substitution for it. So now let me rewrite. So I have integral of e to the power of u, and then I have this whole thing is replaced with du over 8. So if you want, I can rewrite this as 1 over 8 integral of e to the u du. The integral of e to the u is e to the u plus c. And then I sub back in my expression, which is 1/8 e to the 4x squared plus 1 plus c. Again, you might have been able to see that, right? Oh, okay, this is probably just an artifact of my chain rule, but you might not have seen that there's a coefficient. You might not have realized that. You might have had to play around a bit. Again, you could have used inspection with some trial and error, or use the substitution method. It is very reliable. That is it. Those are the toughest integrals you can see in IB. That's it. The ones on the front of this page have to do with an extra constant, so it's just messing around with an extra constant. The ones here are very convenient. They always work out because the derivative of the chain rule is included in the integral for us. Our homework is to get to know these more difficult questions, page 300, number 1 to 12, page 302, number 1 to 12. Good luck, and we will see you next time.